Right, for this question on percentage yield, it's a 6-mark question. So it gives you an experimental method, and it's then asking you to calculate the percentage yield from information given in the question, and then explain using the experimental method why that yield is less than 100%. So it says Lucy predicts from the amount of reactants that she's used that she should have made 5 grams. She actually makes 4 grams. Calculate the percentage yield for Lucy's experiment and explain why the yield is less than 100%. So the 2 figures that I need, so I need, that's what she's actually made, so that's the actual yield. And she should have made 5 grams, so that's the predicted yield. So you need the equation here, so anytime we use an equation we should write it out. So percentage yield is equal to the actual yield divided by the predicted yield. Remember, sometimes that's called the theoretical yield. And then times that whole thing by 100. So if I put in these figures from the question, the actual yield, if we look here, was 4 grams. The predicted yield was 5 grams. So that's 4 divided by 5 times by 100, which if you stick that into your calculator will give you 80%. Now, for this question, it's a 6-mark question. Most of your marks are for this percentage yield. So that's 4 marks of your 6. So as 6-mark questions go, this is actually a relatively easy one. So for the remaining 2 marks, we need to look at this method. So excuse the wobbly camera here. So we need to look at the method and see where they might have lost some product. So remember, there's the difference between the actual yield and the theoretical yield is because of things you've done in the experiment. So we need to look at the method and find these. So what we've done is measure out the sulfuric acid using a measuring cylinder and then transferred that to a beaker. So anytime we transfer any solutions, we're going to lose some. So there will be some left in the measuring cylinder. So you won't, if all the reactants, so if we assume we're measuring out something like 25 mils of sulfuric acid, because I've measured it out in a measuring cylinder and then transferred it to something else, I will have lost some of that. So some of the reactants were left in the measuring cylinder. Right, I've then weighed out the copper oxide in a weighing boat, and then again I've transferred that copper oxide to the beaker. So there will be some of the solid left. And we should really name the solid, so it's the copper oxide. So some of the copper oxide will be left in the weighing boat. I've then stirred using a stirring rod. So when I've done that, some of the solution will be left on there. Right, when the reaction is finished, so there's no more bubbles, you stop stirring. Then remove the unreacted copper oxide using filter paper and a filter funnel. So anytime we're using filter paper and we're filtering something, we could have a loss of solid. But in this case, we're removing the copper oxide. So that's not going to be that big a problem because that's stuff that hasn't reacted anyway. So place the copper sulfate solution in an evaporating basin and heat until the crystals start to appear. Now, any time we get, so I'm heating here, I'm not going to try and draw a Bunsen burner because it's beyond my drawing skills. So if I'm heating something strongly, what tends to happen is some of this solution will spit out and we'll lose it. Okay, so we heat it until crystals start to appear. We then leave the solution to cool and we then filter. So it's this filter bit here where we're going to lose some product. So these crystals are the product. So when we filter it, we're going to lose a little bit on the filter paper. And the other place we're going to lose it, so if we think about it, so again my dodgy diagrams, so I'm going to lose, so I'm going to collect my crystals here. And then we're going to have a solution, the filtrate, that goes into here. Now, some of this copper sulfate will still be dissolved in here. And then we allow the crystals to dry, and then we weigh them. So I'm going to write that into a proper 6-mark answer. So if we look at what it wanted us to explain why the yield is less than 100%. So I need to write this down here. So the yield is less than 100% because, and remember, I can't do bullet points for this because it's a 6-mark question, so I need to write in full sentences. So as well as what we've highlighted, there are standard points that we can make for this. So anytime we've got a reaction, the yield might be less than 100 because either some of the reactants are unreacted, or it might be that there might be a side reaction. So this was because some of the reactants have not reacted, or there might be a side reaction making a different product. Now, if we look back at what we've highlighted, so we might have lost some solution. So some solution might have been lost during transfer from the measuring cylinder to the beaker. And really, I've not been very good there, so I should say some sulfuric acid solution. Likewise, some copper oxide might have been left in the weighing boat. Okay, now if I look at this again, so I've got the transference lost of the copper oxide and the sulfuric acid. So the next important bit, I'm going to ignore the steering rod here because we don't really talk about that unless we're talking about A level. So we're then going to look at the evaporating base. And so when the copper sulfate solution was evaporated, some of the solution might have left the evaporating basin by spitting out. And then we've got the filtration bit. So they're the two bits that we need to worry about. So let's just find this. So when the copper sulfate solution was heated, some of it may have spat out of the basin and been lost. Okay, and then during filtration, some copper sulfate crystals might have been left on the filter paper also some copper sulfate may have still been dissolved in the filtrate. Okay, that's all the answer done. I'll scan that in or write it up so that you can have a proper copy of it because it's difficult to see on here. Okay, thank you for listening. See you next time.